Most of what goes wrong in a distributed system, you find out about eventually. The question is how. Sometimes it's an alert. More often it's a customer, or a number that doesn't add up at the end of the quarter, or an engineer who happened to look at the right thing on the right day. By then it's been going on for a while. That gap between when something breaks and when anyone notices is where the real damage lives. And you can't close it by adding more dashboards, because dashboards only show you the failures you already knew to expect. So today we're going to give a light introduction to Insights, a tool we've been building here at Synadia that's meant to close exactly that gap. We'll break something on purpose, look at it with the tools you'd normally reach for, and then see what Insights does with it. Let's get into it. So here's where we left it. Something in the system is broken, and nothing is going to tell us. No error, no alert, no log line. Every component involved is doing exactly what we configured it to do, and the result is still wrong. The first place anybody goes when they suspect something like this is the command line. It's right there, it's fast, and it's the tool we actually trust. And it's not that it can't find this. It can. Everything we need is in there somewhere. The problem is that the command line only answers the question you ask it. So you have to already suspect the problem, already know which command surfaces it, and already know what you're looking at when it comes back. Ask it the obvious questions, and it will cheerfully tell you everything is fine. So let's do that. Let's go poke at this thing the way anyone would on a Tuesday afternoon and see how far the CLI actually gets us. I want to show you a failure that I think is one of the most unsettling kinds there is. It's where nothing breaks, nothing throws an error, nothing gets written to a log file. Every health check you've got stays green, and 10,000 messages are destroyed. Nobody makes a mistake anywhere in this. No bad config, no bug, no operator doing something silly at 2 in the morning. Everything works exactly as designed, and that's the problem. So 3 words before we start. A stream is a logbook. Messages get written into it and numbered. 1, 2, 3, and on forever. A consumer is one application's bookmark in that logbook. It remembers the last page that an application read. 2 applications reading the same logbook have 2 separate bookmarks and they move independently. And a retention cap is a size limit on the logbook. Ours says, keep only the most recent 2000 messages. When message 2001 arrives, message 1 gets torn out to make room. And that's completely normal. It's how you stop a disk from filling up. So here's the sentence this whole thing hangs on. The logbook has a limit. The bookmarks do not. So here we go. Let's say analytics crashes. Traffic arrives and fulfillment, still running, reads all of it. Analytics lags behind. The stream is capped, so the oldest messages are deleted to make room. The CLI will show a backlog of unprocessed messages. But you're not really aware of what you're actually losing. Commands read that everything looks okay. Because these 2 numbers live in 2 different places, nothing ever really connects them. When analytics is restarted, it pulls once, catches up, and all those old messages are gone. So here's our setup. We have one NATS server right now running. JetStream is switched on. That's the part of NATS that keeps messages on disk instead of just forwarding them and forgetting them. It's a single server, not a cluster. Nothing in this failure depends on replication, and it happens exactly the same way on 3 nodes. There would just be more on screen. On that server, there's one stream, one logbook, called orders. It's the one with the 2000 message cap. And 2 applications read it, fulfillment and analytics. Each has its own consumer, its own bookmark, named after it. And that's the whole system. One server, one stream, 2 bookmarks. Here are the 2 applications. They do the same thing. Read messages, acknowledge each one, repeat, nothing clever. I've called them fulfillment and analytics. Both are reading the same logbook, called orders. There are 1,000 messages in it, and both of them have read all 1,000. Look at the 2 windows. Both say the same thing. Stream sequence 1,000. Both bookmarks are on page 1,000. These 2 are identical and both healthy. And remember that because in a minute they won't be, and the only difference between them is going to be 1 keystroke of mine. And that's it. the entire cause of everything that follows. I stopped an application, it exited cleanly and printed one line and shut down normally, exit code 0. As far as anything is concerned right now, that app finished its work and went home. And if you read what it says on the way out, it acted everything it saw. Analytics did nothing wrong. It has no idea anything is about to happen to it. And now applications stop all the time. This is the single most ordinary event in running software. One thing to notice, the bookmark stays behind. It lives on the server, not in the app. That's deliberate, and it's what you want. It's how an app picks up where it left off after a restart. It's also what's about to go wrong. So I'm going to run this command I made. All I'm doing here is publishing 12,000 new messages into orders. I'm not deleting anything. I'm not changing any settings. I never touch analytics. It's gone. It's not running. Fulfillment is still going, and you can watch it in window 1 riding the wave up, no trouble at all. So I skipped ahead a little bit, and now the newest message is about to be 13,000. The oldest message, still in the logbook, is about to be 11,001. Everything before that has been torn out, because the cap says to keep 2,000 and the server honored that cap. And analytics is still sitting on page 1,000. Page 1,000 doesn't exist anymore. Messages 1,001 through 11,000 were deleted before analytics ever read them. No error was raised to any client. No warning was written to any log. So the caveat here, that bottom table, because I want to be straight with you, that messages lost number does not come from NATS. It comes from about 9 lines of code I wrote in this repo that compares two numbers. Nothing in NATS will tell you 10,000. And now I'll show you. The first place anyone would look, tell me about the stream. 2,000 messages under a 2,000 message limit. That is a stream doing its job perfectly. There's nothing to complain about on the screen. And now another check. I'm going to run a new command. We're going to do stream report to get a report on our stream. Lost 0. To NATS, lost means messages on the disk failed to keep, corruption, hardware failure, something went wrong. Messages deleted on purpose to honor a limit aren't lost. They were discarded, exactly as instructed. So lost 0 is true. It's just an answer to a question nobody asked. This isn't a failure in NATS. This is a failure in our application. So fine, let's not ask about the logbook. Let's ask about the two readers. And this is the closest NATS ever gets to telling you. Both bookmarks are on screen, 1,000 and 13,000. The gap between them is enormous, and somebody who already knew what they were hunting for could spot it right here. But look at what it actually says. Unprocessed 2,000. That reads as, this reader is 2,000 messages behind, a small backlog, the kind that clears itself in about a second. Every application that's ever briefly restarted looks exactly like this. And 2,000 is the wrong number anyway. 2,000 is what analytics is about to receive. It says nothing at all about the 10,000 it never will. Nothing on the screen is wrong, nothing on it is alarming either. And there are other commands in NATS that can help you diagnose things, but that's about as close as we're going to get to showing that an issue had occurred. Since technically, it's not really a NATS issue. And now, let's imagine you're the engineer that wakes up in the middle of the night and notices this consumer has a backlog. So you restart the app, you watch the backlog clear, and you close the ticket. That is the correct instinct, and it's exactly the right thing to do. But 10,000 messages were destroyed, and there is now no record anywhere that they ever existed. Not in the logbook, not on the bookmark, not in a log file. So just a quick recap on why this happened. 1, the two numbers live on different things. 2, every single number is correct. And 3, nothing was watching when it mattered. Let's see how a setup with Prometheus and Grafana helps us surface this issue. So we saw the CLI and what it was lacking to help us surface this problem. Let's get a little more visual and see what we could expect from Grafana and Prometheus. All right, so I just showed you a failure that destroys 10,000 messages without raising a single error, and I showed you that the NATS command line is not really good at seeing this. So one might think the obvious answer is to put a dashboard on it. So I did. And I'll be straight with you from the start. Prometheus can detect this. The problem is that nobody really writes the query to do so. So this dashboard isn't mine, and it kind of matters. So we have some panels here for storage, memory, connections, consumer counts, message rates, and delivered totals. Some of these panels will be helpful to find and diagnose the problem, but only if you're looking for it. And now I did make my own custom dashboard that actually surfaces the problem. So you need to be somewhat of a NATS insider to really know where to look. Now back to my main dashboard. So again, same scenario. My fulfillment application will be up and my analytics application went down for whatever reason. And now I'm going to start publishing our 12,000 new messages over about 8 minutes, so we might speed it up. So let's watch while it happens. We should start seeing some numbers move shortly. And there we go. We can see message rate just shot up. We can also look at our messages per second. This shows how fast messages are coming in and how fast the consumers are eating them. A consumer keeping up looks like a mirror image, the same height above and below. The panel works it out, how fast the backlog is growing and how fast the consumer is chewing through it, which is fine normally. And you could get a hunch that something's wrong if you look at this, but only if you really know what you're looking at. And the backlog will climb here for analytics. We also have stream message count, 2,000 pinned for the entire run. 12,000 messages went into the stream, and that line never moved again because every single one of them pushed an older one out. And here's a panel you'd actually reach for, pending messages. It says 2,000 for analytics. Again, 2,000 is the backlog. And here's the dashboard that is asking the right question. This is my custom dashboard that doesn't ship with anything, and it turns out to be the whole story. Red is the logbook's floor, the oldest message the stream still holds. It starts at 1, and as the cap does its work, it climbs. At one point, it'll be 11,000. Orange is analytics bookmark, flat at 1,000 where the app left it. Green is the other application riding up with the traffic to 13,000. Eventually, red crosses orange, and that crossing is the moment. Before it, analytics is merely behind. After it, everything between the orange line and that red one has been deleted, and analytics was never going to get any of it. So let's watch this happen. So for this dashboard, those numbers have been in Prometheus this entire time. We created the query to do this. And there's another caveat. The exporter doesn't publish these two by default. There's a flag, JSZ equals all. And without it, none of this exists. So you turn it on. But turn it on and you still have no dashboard, no alert, and no comparison. You have to write it. And I couldn't find a dashboard like this on Grafana at all. So writing this query is easy. Knowing to write it is the entire problem. Back on the ship dashboard, there is a panel called Total Delivered Messages. If you were hunting for this failure, this is the panel you would open. It sounds exactly right. And you can see it reads 1,000 for analytics, and it's flat. So there is a problem there, if you look hard enough. But again, it just shows us that analytics is down. And when we bring it back up, we're going to lose all those messages. Now watch them disappear as the orange line and red line meet. All those messages are gone, and I wouldn't have known better for it. So Prometheus can do this. I just need to know that I have the right flags on the exporter. I need to design the right query for what I'm looking for. I need to have some expertise to know what to look for. And then I need to make the proper dashboard for it. So how many times do I have to do this for however many problems exist? I could end up having 100 different dashboards. I do want to give Prometheus and Grafana their dues here because they earned it. Last time when the app reconnected, the evidence was gone instantly and completely, and here it isn't. Prometheus kept every sample, and you can watch the whole thing happen after the fact. And that's a real advantage, something the command line couldn't do. These things aren't mutually exclusive. You can use them together. But in order to catch this problem, you would have to have some NATS expertise. You would need to know what to look for and how to query to make that problem surface. Instead of needing to build all these panels and have that expertise, that's basically what Insights gives you. Now that we have a rough idea of how Grafana handles things and where it can fall short, let's check out what Insights does. All right, let's do our little primer. And this is the general structure for Insights. Insights is one binary. Every minute it asks the cluster for its state, writes that down, checks it, and serves the answers. 5 stages in that order. It can be broken out, but for our purposes right now, we're just going to describe it in its simple form. It asks over NATS on the system account. 13 requests. The first is a broadcast that discovers every server, so there's no target list to maintain. The scraper never writes to the database. Every reply is published to a JetStream stream, so the indexer reads it at its own pace and catches up after a restart. The indexer decodes each reply and turns names into integer keys, so a consumer row can carry its stream's key. That map is rebuilt from history at startup. Those rows are bulk loaded into an in-memory copy of the schema called staging. A pass accumulates there, and nothing has reached the stored history yet. When the pass is complete, one transaction copies staging into the stored tables and stamps the epoch. If any part of it fails, the whole pass rolls back and replays. Inside that same transaction, 142 SQL checks read the pass and write their findings to a table. A finding is never visible before its data. After that, it's all reading. The web UI, a Prometheus endpoint, a NATS query API, and webhooks all read those same tables. So what does this dashboard look like? Let's look at the web UI. So here we are on the system dashboard. As you can imagine, this shows us a high overview of all of our different areas within our system. You get clusters, servers, connections, etc. We also get grading on various different topics. So you can see everything going on in your system in one place. And Insights works a little different. It takes epoch snapshots, not just metric samples. All of these checks ship with Insights. And that's where you get the expertise. Findings attached to entities and not to just dashboards. And history outlives the symptom. This is a big one. You can go back in history and see what went wrong and when, even after it was remedied. Beyond just the checks, the epoch data is queryable, so you can query the state directly. Now again, I have the same setup we've had since the beginning. 2 applications running, both of them pre-populated, they consumed 1,000 messages each, they're all caught up. And we have 1 server running. I'll speed this up and you can see every 15 seconds we collect a new epoch. Let's look at our stream. You can see our seeded 1,000 messages in the order stream. And there's our 2 consumers, our 2 applications. And we can click into this stream and see more. And when we do that, you'll see more details about the specific stream. There's our messages, there's our consumers. We can look at our utilization here, and you can see the first sequence 1 and the last sequence 1,000. So everything lines up. Here's our consumers. We have fulfillment and analytics, and they both actually have a health alert on them. So let's go look at one of them. Here's our healthy consumer, fulfillment. It's all caught up. So these events actually make sense. It's drained and it's inactive. And these events are historic. So you can see all the things that occurred on this consumer over time. Let's go look at our analytics consumer. So it's healthy too. It's all caught up. We're set up properly. Fulfillment and analytics are lined up. And now I'm going to break it. Analytics is going to crash like it always has. And while that happens, we're going to publish 12,000 messages. And then we're going to bring analytics back on. This is where we lost our 10,000 messages before. And I'll speed this up a little bit. Every 15 seconds, we'll get a new epoch. And we expect to see a new event pop up in the events history. All right, there we go. New epoch says drained consumer. So we have 0 pending on the stream, and now our consumer is going through that backlog. And once it does, we should see something. If we go over here and look at it, we can see we still have 1.5K pending. Let's watch it and see what happens. And look, Insights caught it and flagged it. It's letting us know something went wrong and we delivered below the stream first sequence. And this event occurred, it's historic, we can always go back to it, we can look at it and see what happened over time. And you can see this isn't the only check that Insights does. And Insights already ships with a bunch of checks created by people at Synadia. And this is the expertise I'm talking about. Insights performs these automated checks, and you can actually go to this page and see all the various checks it performs. We can actually even find our error on here and click into it and learn more about it. Here it is. This gives you a whole overview of the causes and fixes for this particular problem. So nothing goes unseen, nothing goes unknown, and this isn't something you're going to get with something like the CLI or Grafana with Prometheus. And it spans out over your whole NATS topology. So I paced this video out over time, but it's kind of funny to think about. The time I spent going over the CLI or invested in looking through Grafana and Prometheus, in one epoch, 15 seconds, Insights revealed the issue. We've had some real client tickets pop up that Insights could diagnose. A KV mirror replication that had been silently stalled, and it lasted for weeks. Discovered only when there was a release that went to update bucket policy. And another where a mirror stream stopped advancing. The customer had no signal until the lag was already large. And these are typically silent issues that you don't notice. But Insights picks up on them immediately. And Insights comes with the expertise, but it also allows you to become an expert yourself. 3 tools looked at the same cluster. The command line said backlog, and it could only reveal the issue if already knew where to look. Grafana is great, but would require me to create custom dashboards and panels for all of my edge cases and issues. Insights said, Analytics. Gave me an event with data on what went wrong and when, and details into how to diagnose and remediate it. All I had to do was point it at my system. Nobody asked it. No threshold, no query, no panel. It just watches and works. This is video 1. We're going to go deeper on Insights from here. You can also learn more on the Synadia webpage. If you enjoyed this, please be sure to like and follow. I'll see you in the next video.